Okay, so we are going to take all that stuff that we did about writing equations of lines and then use lines to make shapes. So that is the plan for the day. So there's going to be a lot of graphing, some distance formula here, some area, so stick with me and this shouldn't be too bad. So it says graph the 3 lines below. Oh, by the way, we're on lesson 8. So in your packet, make sure you're on lesson 8. So what we're going to do is we are going to create multiple lines that make a shape. And we are going to start with these 3 lines right here. So I have y equals 3x minus 1, which I'm going to graph in black here. So I'm going to go start at -1, up 3 over 1, up 3 over 1, down 3 left 1, and then sketch that line in here. And because I'm going to be graphing multiple things at once, I'm going to make sure I label it. And then in red, I'm going to graph y equals 3 minus x. So I start up at 3. And if I have 3 minus x, that means my slope is -1. So down 1, right 1, down 1, right 1, and so on. So there's y equals 3 minus x. And then x equals -1 is a vertical line through, the place where x equals -1, which is right there. So there's x equals -1. Ta-da! And it says find the area of the triangle created by the intersections. What? There's a triangle there? You can barely see it, but there is. It's right here. It's this guy. Do, 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 do. And so I have this triangle right here, and if I want to find the area of a triangle, I can do base times height divided by 2. So I'm going to come in and put this in orange here. So if I want to do base times height divided by 2, I'm going to consider this my base. And so if I count my base here, 1, 2, 3, 4, 5, 6, 7, 8. So my base is 8. And then my height, sorry for the jumpies. My height right here is this distance, right in the middle of the triangle. And that's 2. So 8 times 2 is 16, divided by 2 is 8. Ta-da! So that's how you can use lines to make figures on a grid. Fantastic. All right, so now we're going to come down here to this rectangle. And it says, give the coordinates of 2 points inside the rectangle. So I don't know, like right here and right here. So I'm kind of trusting that you guys can do that. So if this is 1, 2, and that's 15, 7, I don't know. If this is 1 and that's 15, that might be like, I don't know, maybe 5. And if that's 2 and that's 7, then this could be, I don't know, 5. So this could be the 0.55 if I wanted it to. And this could maybe be like 13, 4. Okay, and the idea there is just to get you guys to think about, I need to make sure my y's stay between, my y's need to be between 7 and 2, and my x's need to be between 1 and 15. Then it says give the coordinates of 2 points on the boundary of the rectangular region. So by the boundary, I mean not the corners. All right, so let's talk about the boundary here. It's not that boundaries can't include corners, but when I wrote this, I meant not including the corners. So like if I wanted to pick this point right here, this is along this top line, which is a horizontal line going through 7. Does that make sense? So this would be, I don't know, like 3, 7. And then if I pick this point right here, this is along the line where x equals 1. And then y would be somewhere between 2 and 7. So I'm going to go with 5 again. And that might be 2 points on the boundary. Okay? So then what we're really going to do with this is I'm going to take all those ideas and say, well, what if I had to take the picture and then write a system of equations that models it? So if I want the top, make this a little bit thicker here. So the top is this purple thing, and that passes through y equals 7. So the top is y equals 7. Whereas the bottom is this guy right here, and that would be y equals 2. And then if I look at my left side and my right side, my left side is x equals 1. And my right side, I'm going to make that light blue. passes through, well, let's see, what does x equal over here? Oh, right, it's 15. Okay, you should be able to do that. I know I did it quickly, but you should know horizontal lines are y equals and vertical lines are x equals. Okie dokie. Then it says find the perimeter of the rectangle. Okay, so I'm going to erase all this stuff and think about my perimeter. So if this is a rectangle, my x went from 1 to 15, so the bottom is 14, and my y goes from 2 to 7, so my height there is 5. So if this is a rectangle, those would be 14 and 5 as well. So my perimeter would be 14 and 14 and 5 and 5, which is going to be 38. Then it says underneath that was the area of the rectangle. So the area of the rectangle would be 5 times 14, which is going to be 70. Again, the point of all this, I'll shrink it down in case you missed anything. The point of all this here is you can take equations of lines, throw them on a graph, and get shapes out of it. And you have to remember how to manipulate shapes, perimeter, area, stuff like that. Okay? All right, so we are going to move on here, and we are going to do example 3. So example 3 says, draw the triangular region in the plane given by all those points. Okay, so plot these points along with me here. So A is at 0, 0. B is at 2, 1, 2, 3, 4, 5, 6. And C is at 1, 2, 3, 4, 2. So there's triangle ABC. And then it says write in a set of equations that creates this region. Okay, so now I'm writing the equations, and these aren't horizontal and vertical. So I either want to do some things maybe in y equals mx plus b form, or y minus y1 equals mx minus x1. You get a choice. It depends on what you got. So I'm going to do the equation of the bottom, also known as AC. And so if I look at AC, the y-intercept is right here at the origin, so my y-intercept is 0. So I'm going to go with y equals mx plus b, but my y-intercept is 0. That's just the beeping noise from the bell. And then I have to count my slope, so I go up to right 4. So my slope is up to right 4, or I could write that a little bit simpler as y equals 1/2 x. And then if I want the left-hand side, that's going to be AB. I'm going to still start at 0, but to get from A to B, I go up 1, 2, 3, 4, 5, 6, right 2. So it's going to be y equals 6 over 2, x plus 0, which is y equals 3x. And then last but not least, for what do I need? The right-hand side, which I'm going to call BC. I don't have a y-intercept. So I'm probably going to go with y minus y1 equals mx minus x1. So let's see. My slope here from B to C is I'm going right 2, down 1, 2, 3, 4. So if I did rise over run, my slope is negative 4 over 2, which is really just negative 2. And then I have y minus y1 equals mx minus x1. And I'm supposed to use a slope of negative 2. And then I can use either point B or point C. I'm going to use C just for fun, which is 4, 2. So I put m in for m and put 4 and 2 in for x1 and y1. Y minus 2 equals negative 2x minus 4. Okay, so you have to be able to look at a picture and figure out the equations that made it. Make sure you know how to do that. If you don't know how to do that, you should be coming to see Mrs. Vibber. Okay, what's the perimeter of this region? Give your answer in simplest radical form and round to the nearest tenth. Okay, so if I want perimeter, I have to do the distance formula, or honestly, I think even better, let's just kind of make some triangles here. I'm going to go with orange. So if I want to find the length of AC, that's really the hypotenuse of this triangle. And when I get from A to C, I go over 4 up 2. So the length of AC, actually I'm going to put a semicolon here, is going to be 4 squared plus 2 squared equals C squared. Just use Pythagorean theorem. So that's 16 plus 4, so 20 equals C squared. C equals the square root of 20. I'm just going to leave it unreduced for now. And then I can do the same thing again, but we'll go with purple this time, to find the distance from A to B. And say, okay, when I went from A to B, I went up 6 over 2. So for AB, 6 squared plus 2 squared equals C squared. And that's going to be 40. So C is radical 40. And last but not least, I have BC. I want to do a fun color. We're going to do poopy brown. So if I want to go from B to C, I can just follow this poopy brown triangle here. So that went over 2 and down 4. So then BC is 2 squared plus 4 squared equals C squared. So that's another 20. So if I want to give my answer in simplest radical form, the perimeter is the sum of root 20, root 40, and root 20 again. If I simplify these, I know I'm going quickly. We'll go over it again. If I simplify these, 20 is 4 times 5. So that's going to be 2 root 5. 40 is going to be 4 times 10. So that's 2 root 10. And another 2 root 5. So my perimeter in simplest radical form is 4 root 5 plus 2 root 10. And then it said also rounded to the nearest tenth, so we would just pull out a calculator and then type in 4 root 5 plus 2 root 10. You know, eventually. Come on, there we go, yay! 4, nope, not y equals, stupid fingers. 4 root 5 plus 2 root 10 is 15.268. 15.268 would be 15.3 if I round to the nearest tenth. All right. The last thing I'm going to do is find the area. So the last one, we did base times height divided by 2. This time, I can't do that so much because I don't have a horizontal or a vertical base. This is slanty. So what we're going to do here is we're going to get a little bit creative here. And let's do gray. And this is one of those where you box it in. And we did this before one other time, where what we're going to do is find the area of the big gray rectangle and then subtract out these little white triangles, which will leave us with the area we really want. So across the bottom, we have a width of 4. Straight down here, I have a length of 6. So the area of the big triangle, or big rectangle is 4 times 6. Then I have to do each individual triangle a little at a time. So that was a 2, that was a 2, and that was a 2. And so there's the big area, and then I have to subtract out base times height divided by 2. Subtract out another base times height divided by 2. And another base times height divided by 2. 2 times 6 divided by 2, 2 times 4 divided by 2, 2 times 4 divided by 2. So I have 6 times 4 minus 6 times 2 over 2, minus 4 times 2 over 2, minus 4 times 2 over 2. And yes, I know there's a faster way to do this, but I'm just trying to be consistent. And da 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 da, you get 10. Okay, so your homework, which I will be looking at tomorrow, is to do the entire problem set that follows this. Okay, so Unit 6, Lesson 8 problem set. You're going to be doing a little bit of area, a little bit of perimeter stuff. So get started now, and I will see you later. Bye.